Let us solve the exercise number 4 in the part B of data structure lab. In this exercise, we are supposed to write a program to implement all the operations on the sorted singly linked list. So let's go ahead and let's perform all the operations on the sorted linked list. Now what I'm going to do is I'm going to perform only these operations. General operation that I'm going to perform is first of all is one is to insert an element into the list, delete an element into the list, and I'm going to list or display the element of the list. There is one other operation generally performed, and that is a search operation. I will not perform that search operation because I strongly feel that that will make the program too lengthier to be implemented during the examination. So generally people go for insert, delete, and then list the element. That is what is generally done with the queues and with the stacks. So I also assume that it is the same step that everybody is going to follow. So let's go ahead and let's do the operations. So let us first look at how do you create a linked list. Now we know very well we have to create a node in the linked list. There are two parts in the node. One is the part that handles the data, and the other one is a pointer to the next element. So this is the general thing that we do in the linked list. So we create a node which contains two parts. One is the data part, and the other one is a pointer to the next list element. So let's go ahead and let's do that part over here. I'm going to go to my code block here, and I'm going to go and create a new file here. So I'm using the code block here, and I'm going to create a new file, and I will select the C++ source. Let me click go, and let me click next, and C is my programming language. So let me select the folder where I'm supposed to store it. See to it that you are storing in the same location where you have already been saving your files. So let's say I'm going to say sorted LL, sorted linked list. You can give any name for your program. Just click finish, and I'm going to use the general include statement. So I'm going to say include stdio.h. So this is the general one that we usually include in almost all the C program because we want to perform some input output operation. Apart from that, I'm also going to include standard lib std lib.h. Now this I need it because of a function malloc function which I'm going to use for allocation, that is dynamic allocation of the memory. So we are supposed to implement this node which contains one part is the data part. So one part is the data, and the other part is a pointer to the next location. So this is what we are supposed to do it. So let's create a structure that will resemble this one. So I'm going to say structure. I'm going to call this one as a node. You can type n in small case, but I will type it in capitals. Otherwise, every time you have to switch the press the shift on the keyboard, but I think you can do that thing. Okay, so first part is the data. Next part is a pointer to this node itself. So pointer to itself. So I'm going to say node star, and I will call it as next. So this is what is there. So you have the first part here, and that first part happens to be the data part, which is here, and the pointer, which is of the same type, pointer to the next node. So that is what is going to happen. So a pointer to the next node there. So this is what I have implemented here. So let us first try to create a node. First thing is I'm supposed to create this kind of structure here. I have just created a blueprint of the structure. I have not created any structure. So this is just a blueprint. This is how the things would look like. Now what if I really want to create a this kind of structure in the memory? For that I'm going to say, remember, once I create a structure of this type, I will use a pointer to point through that particular structure. So I will use a pointer that will point to that structure. In other words, my function will return a pointer to this memory location. So in the memory location, wherever this structure is there, I will give a pointer to that particular structure in the memory. So let me use a structure pointer. So I'm going to say structure node pointer. So this function will return a node pointer to me. That means a pointer. In other words, within the memory, I'm going to create one structure of this one uh, node of this type or one element of this type, and I'm going to return a pointer to that element so that I can use it in my program. So that is what I'm saying. I'm going to return a pointer of type struct node. So this pointer I'm going to return. That means to say that I'm going to return that one. So let me call this function as create, create, create. Okay, and it's going to take a value. So whenever I want to create a node, I'm going to give the actual data value. For example, if it is an integer, I'm going to say 55. So this node will have the data as 55. So data is 55 real value, and it's going to point to the next element. Now generally I don't know where it is going to point, so I'm going to initialize and I'm going to say that it will point to null. So in other words, it's going to point to null value. So this pointer will be null because I don't know where it is supposed to point. I will create it and I'm going to say this next pointer is null because I really don't know where that next is supposed to point at this stage. Later I may change that value. So this function will take a value like 55 or 95 or whatever value you are going to give, and it's going to create a node for me. So how do I create a node? Remember, I'm going to get a pointer to that one by whenever I use the malloc. So I'm going to use the node star to say that I will call this one as a new node. You can call it as anything, a new node, and I'm going to use the malloc function. So if you use this malloc function, remember malloc is available under the stdlib.h, and I'm going to give for the malloc you have to give the size of the structure so that it can reserve some within the memory. So if you have the memory here or heap here, the malloc will you have to specify the malloc what is the size that you want to reserve within the memory, what is the size you want to reserve. That is what I'm supposed to give it to the malloc. So I'm going to say size of oops, size of where what on earth is happening? Okay, size of the structure node. So in other words, what did I do here is what is the amount of memory I'm supposed to reserve within the heap. This is equal to the size of this. So that is what I am saying. This is equal to the size of the struct node. So that is this much of memory I want you to reserve. Remember, it's going to return a pointer of the type struct. So I'm going to typecast it, and I'm going to say struct node pointer. So it's going to give a structure that is a pointer to that particular structure. This is what I told you. Within the memory, I'm going to reserve, I'm going to create a node, okay, and I'm going to give a reference to that thing, that I'm going to return a pointer to that thing. Now the first thing is what I have done as of now, what this malloc has done is within the memory, within the system memory, that is within the heap, it has created a structure and it is blank. Now I have to fill this structure with the value that is given over here. So for my function, some value is given like 55, 45, whatever it is, whatever the value that is given, this value I have to place it here. And as I've already told you, because I don't know where is the next location, I'm going to make the next as null. So the newly created node will have its next pointer as null. So let me do that thing. So I have the new node here. That is what I've created. I've created a new node now. Now for this new node, I'm going to go to the new node, and I'm going to say new node. Okay, and the data within that new node is the value, whatever, oops, whatever is the value that is given to me. So in other words, whatever value that is inputted like 55, 45, whatever it is, that is stored inside the data. Okay, and as I told you before, the new node dot next is null, as I told you, because I don't know where this is going to point. So I'm going to say the next of it is null. I'm going to return this new node, whatever new node I've just created. I'm going to return this new node to the calling function. Whoever is calling this function, I'm going to return the new node to them. Okay, done with that. Okay, so let's look at the next thing. What we can do after this. After this, we know how to create a new node. Now let us think of inserting a node at a proper location. Now, in order to create a linked list, you know very well there is one special pointer called as a head pointer that will point to the first element of the linked list. So that will point to the first node. Okay, this head pointer. So we need this head. Using the head, we are going to insert a node. So we need two things. One is the head, and the next one is which value I am supposed to insert. So two things I'm going to take. One is the head pointer, and what is the value, like 45, 55, 95, whatever is the value. So I will take two things from the user. So let's go ahead and let's create a function. So I'm going to say, okay, void, this function will not return anything. Void, I will call this function as insert, and I will first get the structure node, okay, structure node, and I'm going to remember this is a pointer to the pointer. So I will use a 2 star here. This will be the pointer to a pointer. So two things, and I will say int value, two things. Don't worry about the pointer and other things, you don't get confused. What I have is only two things I'm taking. One is I want the head, that is the starting point of my linked list. Remember, linked list will start from the head, and you can go using the head, you can go to the all the other element. You need this head, and you need that value that need to be inputted. So two things that I'm taking. So in my function, I take two things. One is the head, other one is the value, two things. Okay. And first thing is because I'm inserting the new node, remember I'm going to create a new node. Let me just say that I'm going to create some new node. I don't have anything here, but I'm going to create a new node like this. How can I create a new blank node inside the memory? So I already have the function called as create function. So I'm going to use that create function, which will return a pointer to the struct node. So I'm going to go and create a new node. So I'm going to say struct node, and it's going to return a pointer. I'm going to call this one as a new node. Okay, and I'm going to say create. Okay, some people will combine this whole thing inside this function. Well and good. You can reduce the effort in doing that thing. So if you copy this whole thing, if you copy this whole thing here, you can reduce that function, but I'll leave it as it is because we are creating it and we are inserting it. So two things I want to say, because they said what are the different functions you can perform on it. So one is you can create a node, then you can insert a node, and then you can uh, list the node as well as you can delete the node. Some four operations that we are going to perform. So that is the reason I have used a separate function called as create function. You can combine this thing, you can copy paste it over here, but it's up to you. Okay, okay, so let's do this particular thing. Okay, so now next one, let's look at the first scenario. First scenario is you don't have anything in the linked list. So in other words, linked list is blank. When do you say the linked list is empty or linked list is blank? If the head itself is not pointing to any element, for example, in this case, the head is pointing to one element. There is one element here. In that case, this linked list is not empty. It is not blank or it is not empty. So when you say the linked list is empty, there is nothing in the linked list. When the head itself is pointing to the null, that means the list is empty here. So if the link is empty, then we are supposed to do something. Okay, So let us look at that scenario now. What if if this list is empty? So if I'm going to say if, okay, remember I used pointer of pointer. So if star head, okay, if this is equal to null, okay, so that means to say that head itself is null. So head is not pointing to anything. Head, you look at here, head is pointing to null. Head is null. In other words, head, pointing to null means head is null. If the head is null, okay, that means it is the first, this is a blank list that is given to me. In that case, what to do? Okay, if the head is null, you are supposed to make the head point to the new element. That's simple as that. You make the head point to the new element. So simple as that. Okay. So how can you do that thing? So you are going to say, let's go over here. You are going to say, let me put this here. You are going to say star head. Remember, this is a pointer of pointer. So star head is equal to new node. Okay, new node. Which is this new node is the one that I just created, the blank node that I just created. Okay, so this is simple as that. If it is what do you say? If it is the blank node, if it is a blank node, remember, sorry, if it is a blank linked list, that means it is an empty linked list. That means the head is null. So what you are going to do is, you remove this null. Remember, it is pointing to something. Remove this null and make it point to the first node. Whatever value it is, like 67, whatever some value is there, that value. Say, remember, you sent that value here. So whatever value that was taken, that value, whatever that value is there, you just put it and make the head point to the first element. So this is the first case. Okay, so I hope you understood. So if the head is null, if the head is pointing to the null, this is what I have said. If the head is pointing to the null, then this is the straightforward thing. It is done. Now, what is the next scenario? Now let's assume that head one element has been inserted. Head is not null. That means something is there in the head. I don't know what else is there. Some assume that this will continue. Okay, this will continue. A lot of things will be there. A lot of things are there. I don't know how many are there. I don't care how many are there. But head is pointing to not null. Head is pointing to some node. That means some elements are there. Now suppose if I, in this scenario where head is not null but it is pointing to some list, suppose if you are asked to insert 20, suppose you are asked to insert this node into the linked list. But what is the problem? Problem is you are supposed to implement a sorted linked list. That means the element must come in the ascending order. So this 20 you are looking at here, 20. What is the sorted order? If you want to get it in the sorted order, you must first move this 45 next and put the 20 and then put the 45 and make it a point to the null. So this is the order. In that case, 20 in the ascending order, 20, 45, 55, 95, something like that. So it must come like this. So now let me come back to the scenario, what I have it here. The situation, current situation is you have 45 here, you have 45 here, and you are asked to insert, let me just take it slightly up. Your head is pointing to 45 here, and you are asked to insert a new node. So this is a new node. You just created a new blank node and you filled it with the value 20, and you are asked to insert this here. How do you insert this here? First one, make this one point to, remember, you can't just okay, this is pull it here. It is not possible. You have to have the reference to it. Remember, these whole things are there in the memory. They are not continuous. One is here, one is here, one may be here, one may be there. You must know this is linked to here, this is linked to here, this is linked to here. So they are linked, interlinked. You just break one link, and if you don't take care of the list, this whole thing will collapse. So it will, in other words, if you do this one, if you have a link like this, okay, many items are connected, so this may be connected here, this may be connected here, this may be connected here. If you break one of the link, suppose if you break one of the link, you lost all the elements, all the other connection. It may be connected to something else, you lost all the connections, so you must take care of the link. So if you break the link, it's like a chain. If you break the link there, you lost the remaining part of the chain. So you cannot simply say that, okay, I'm going to pull this here. When you pull this here, what you lost the chain altogether. So this link is broken. When this link is broken, you will not be able to get a hold on this particular location. It's gone altogether, so you can't do that. So what is that you are supposed to do? Remember, we have the location, this head, that is why we say this is the starting point. We always have the reference to that head. So this is our starting location, and we keep that head with us, that means that pointer with us, so that we can go and go through all the elements in the list. So what is that we are going to do? We know that the head is pointing to 45 because this is our location. This we are keeping it safe. This location we keep it safe so that we don't lose that location at any time. So using the head, I know that I can reach to 45 because that link is there. So I'm going to take this same link, whichever the head is pointing, and I will use that same link. Remember, head dot next is this location. So I will also make this one point to the same location where head is pointing, because I know where the head is pointing. Remember, this is my, it is like my reference point. It is my starting point. I know that head is pointing to some location. Head next of the head is pointing to some location. Same location, because I know I can use this head and reach to this location. That means I know this location. The same location, I'm going to make this thing point to the same location. So in other words, I will make this 20 point to the same location where the head is pointing. Let's assume that this is the head. So I will make the head point to the same location. Remember, I still have the control on this one. I have not lost this control. This is my new node. Let me go to the code here. This is my new node, and I have already have the location of the new node. Wherever I created, I have the pointer to that new node. So that means I have not lost that reference of the new node. The new node is there with me still now, so I can always point to this. Okay, done. So what I done is I am making this new node point to the same location where the head is pointing. Done. Now because I have the location, this one is known to me, this location is known to me. I am going to make this head was pointing to 45. Now I will make this head point to this location. So first I will make the, remember, so what did I do? First I created a node, and I will make this node point to the same location where head is pointing. So I will make this node point to the same location where the head was pointing. Next, what is the next thing I'm going to do? I'm going to break this link, and I will make the head point to the 20. So I will make this head point to this 20. So in other words, I will make this head point to this 20 now. So now what happened? The head is pointing to 20, and the 20 is pointing to 45, and naturally 45, there is nothing in this list. As of this list, there is nothing in this list. So next is null, and the next it may the other element may be there. I can go on. So 20 is inserted at the proper location. 20 must come at the proper location. Why did I took all these trouble? All this trouble I took because when I created a new node, I just realized that the value within the new node, that is 20, is less than the value of the first node itself. What is the value of the first node? 45. And what is the value that I want to insert is 20. So I realized that the first node itself has a larger value than the value which is there in the new node. So in other words, a new node must come before the first node. How, when did it happen? The value of the new node is less than the first node, that is the node that is pointed by the head. So the head dot this value, the head is pointing to this value, so wherever the head is pointing, if that value itself is larger than this new value, in that case it must be inserted in between. So two things I'm going to do. Remember, in the first case head was pointing to null. What is the second case? Second case is you have a node that has a value less than the first element. In this case also head must point to this location. So remember, in the first case when the head was null, what did you do? You just made the head point to the node. This is the first scenario when the head was null, which I have already taken care. In the second scenario, what is the second scenario? In the second scenario, the value is less than the first. Head is not pointing to null, head is pointing to a node, but there is one new node which has a value less than the value at a node that is pointed by the head. So what you are going to do, this is what you are supposed to do. This must come before here. So head must point to here. In other words, in both the cases you are going to touch the head. In the two cases you are going to make the head point to something. You are going to make the head point to something. So in this case you are going to, in other words, manipulate the head itself. So I'm going to combine both of them. The first scenario I have already told you, when the head is null, it is straightforward, you just put it here. So this is straightforward, so I have taken care. In the second scenario, let me go with the second scenario. In the second scenario, this value is less. So how do I say that? If this is the first scenario when the head is null, this is first scenario, head is null, straightforward, you make the head point to the next node. So this is done. I've already taken care. Now I'm going to say this is one, or there is one other scenario. What is the other scenario? In the first case the head was null. In the second case, what is the second case? In the second case you have a new node whose value is less than this value. So this value, new node value, is less than a head dot value, wherever the head is pointing, that value. So how can I write that thing over here? Or I'm going to say star head. Remember, head is a double pointer, so head, star head dash value. What is this dash data? So whatever data you have it here. So remember, this is the data that I'm talking about inside the node. So head dot, where is it? Okay, this one. So head is pointing to this 45. So I want this data value. So this data 45. If it is, where is it gone? If it is greater than or equal to, remember I use the equal to because even if it is equal to, same scenario, okay, because if you are inserting 45 also, see, if you are inserting 45, see, already 45 is there. If you are inserting already one more 45 here, it must also come front, okay, one and the same, okay. So let's say 25 you are going to insert. So in this case this must come here. So value that head is pointing, so this head dot data, that is 45, is greater than this value. So this is the value that I am trying to insert, 25. So this value is greater than or equal to the value head dot data. So head dot data, so head dot data, so this is the place, is greater than or equal to the value in the new node. So if that is the case, then same story you have to do it. Head must point. How do you do this? How do you do this? If this is the case, first remember, I know where the head is pointing. First make this point to the this location and make head point to this location. So this will point to 25, head will point to 25, 25 will point to 45. So this is how it should come. So head must point to 25, okay, and 25 must point to 45. This is what you are supposed to do, and I have already done that thing. So head must point to the new node. So that is it. Head is pointing to the new node. The new node that I have created, head must point to the new node. Okay, done. Okay, head must point to the new node. So this is what you have done. Head dot next. Okay. Now there is one extra thing that you need to take care in this scenario. What is that scenario that you have to take? Okay, head, first of all, the, let me go over here, let me do this case over here. So the head must point to, if you just remove this, head must point to here. Then where this is pointing, remember this is null, it will stop. First thing that I'm supposed to do is head is pointing here, point this to same location where the head is pointing. You point to the same location where the head is pointing. How can I write? Make this 25 point to the same location where that is pointing. How can I write that statement? Okay, I'm going to say new node, whatever the new node that I just created, new node, it must point, how do you say, new node dot next, it must point to the location where head is pointing. As simple as that. So what is this statement? If you are wondering what is this statement, this statement means, what does this statement means is, new node must point to the same location where the head is pointing. So new node must point to the same location where the head is pointing. Where the head is pointing. Now move this head to point to the new location. Okay, now make this new point to this location. So first, what is the first thing? First thing is, you have the node here, head was pointing here. You created a new node. First, make this new node point to the same location where the head was pointing. So this is going to point here, and now move this head to make it point to this location. Done. Yes. So two things you have done. So let me put it properly. Okay, let me put it properly. Let me just format it so that it looks nice. So new node is pointing to the head, and the head is pointing to the new node. After that, I'm going to just say I've done my work, so I'm going to say printf. This is just to, otherwise people don't know what is happening. So I'm going to say inserted, and I'm going to use /n, and I will return out of this function. So I'm going to say I will return out of this function. Remember, this function does not return anything, so I will just say return out of this function. So this is one scenario. What is the other scenario? Other scenario is, then let's look at the other scenario. This is the second scenario. Second scenario is, you are not inserting here. You are supposed to insert, let's say you are supposed to insert a element, say 51, okay, 60, let's say you are supposed to insert a value 60. How can I insert the value 60? So you are supposed to insert, this is your new node. Now this is your new node has a value 60. How do you start? Remember, you always start from the head. You start from the head. Okay, you compare the value. Is this value greater than 60? No. You go to the next one. Is this value greater than 60? No. You go to the next one. Is this value greater than 60? No. You go to the next one. Is this value greater than 60? Yes. So where is that location? So this 60 must come between here. So this 60, this node must come here. In other words, this I'm just showing you, this must come, 60 must come here, and then 65 must come. So this is how it should go. So what you have noticed here is you are comparing. You start from the head. You take one value. Okay, you compare whether you check whether this value, this data value, is it greater than the current value. Okay, if it is not, you go to the next one. Is it greater? No. Is it greater? No. Is it greater? Yes. If it is greater, you have to insert it in the previous location, not after this location. You have to insert in the previous location. so not in the current location. So how can you do that thing? How do you insert this in the previous location? For this, I need one more pointer. So what is that one more pointer that I want to remember? When I come here, if you start moving here, moving here, moving here, moving here, you are in this location. But where are you supposed to insert? You are supposed to insert in this location. That means I must know the previous location. Only then, if I know the previous location, I can make it point to this location and make it point to this location. Only then I will be able, because I have already moved here, I don't know what is the previous location, so I need that previous location. So let's take care of that scenario here, and I'm not going to move the head itself. I'm not going to move the head itself. I will take a separate pointer. Remember, if you start moving the head, you lost the control itself. So I will take a separate pointer called as a current pointer, which will start jumping from this, this, and so on. So let's take a separate pointer. I'm going to go over here, and I'm going to create one more variable. So what is the variable? Variable must be of type struct node, and I'm going to call this one as the current pointer. The separate pointer, that it's like you have in the for loop, you have for I is equal to, so I will take the value from 0, 1, 2, 3, 4, like that. Similarly, I am taking one variable called as current, which will go to different nodes. So in your the arrays, you have I is equal to 0, I is equal to 1, I is equal to 2, like that. So similarly, I have the this time I'm using the current as my pointer. So simple as that. Okay, so let's look at the other scenario. Remember, if this is the first scenario which we are not touching, so in the second scenario I will initialize the current equal to head. So what is the meaning? I is equal to 0. You start like that. I is equal to 0, I plus plus, and so on. So in this case also, this current pointer that I am going to use, let me call it this pointer. So this current pointer that I am going to use, I have taken it as CUR in my case. So this current pointer CUR, this is my I is equal to 0. It's like your I pointer. So it will point to the same location. You start from where the head is pointing. Then current will go one step, then current will go next step, and so on. It will jump from 1, 1, 1, 1, like that. So initially current will point to the location where the head is there. So you go to do that, and you keep on increasing. So current will point here, next time current will point here, next time current will point here, next time current will point here, and next time current will point to the null, because there is nothing left. So when the current is pointing null, that means that it is the end of the list. So it's like for I is equal to 1 to n. If you write this in your other programming language, if you write for I is equal to 0 and I less than or equal to something, you write like this. When I is less than or equal to n, that means when it reaches the value n, it is the end of the array. Similarly, when it reaches the null, when the current reaches the null, that means it's all over. Okay, so you start from this head and you keep on until you reach the null. So how can I write that thing? So while, okay, current dot next, remember current dot next, remember next is pointing, look at here, next is pointing to null. So this is a current dot null next. So current dot next, okay, is not equal to null. So you have to keep on going until that. Okay, and so if it is not null, then only you can move it. Remember, if you reach the null, if the current reaches the null, what is the meaning? It is all over, is it not? So if it is not the case, then only we have to do it. Okay, if it is not the case, then we have to keep on moving. Okay, how long we have to keep on moving? Until we get a value which is greater than our value. So if the data which is here, if it is greater than the value that we are inserting, you have to, if it is less, you have to go. If it is less, you have to go here. If it is greater, you have to stop. So, and first one, it should not be null. Next one, what is the scenario? Next, current, okay, dot next dot data, okay, must be less than the value. Okay, so too many things over here. Remember, current was pointing, where is current was pointing to the same location that the head is doing it. So you are just verifying. Remember, if it is a first value, if it is a 35, I would have already taken care here. In the previous case, I have already taken, if it is a first value, if the head, if like this, if it was the first value, I've already taken, I've already talked many times, I won't talk much about it. If it is a first value, it's all over. I have already inserted. If it is the first value to be replaced, I have already done. If it is not the first value, that means from where you should take. You must say current is pointing here. From, you don't take 35 because it is already there. The first node story is already over. So we are starting from the second node. So you go to the next and then take the value. You go to the next element, not this element. Remember, current is pointing to this element 35. Don't take 35 because it is not the first element. We are inserting after the first element. So go to the next element and then take the value. So this is what I am doing. Go to the, where is it gone? Go to the next element and then take the value and compare that value with my current value. If it is less, make it point to the next element, 55. If it is next, so if it's next, go to the next element. If it is less, in this case, see, current dot next is this 35. 35 dot next is 45. This is less than 60. Go to the next one. Make this current point to the next element. How can I do that thing? In this case, okay, make this. I'm going to just remove this because it is unnecessary. There is only one step. If you want, you can put a flower bracket here, but during the examination, that we will spending some time on that. So I will not put the flower bracket. Make the current point to the current dot next. So in other words, what is that I have done? If this, remember, current was pointing here, if 35 is not greater than 60, make the current go to the next location, current dot next. What is the current dot next? Go to this location, make this go to this current dot next location, make this current point to the next location. Again, if it is less, make it point to the next element. Again, it is less, you keep on doing it until you reach a point where current dot next dot data, when this is greater, you stop at that point. Remember, when you reach to the 55, current dot next dot data, look at here what is written here, current dot next dot data, not the current dot data. There is a huge difference. If I say current dot data, that means this is 55. I am not interested in this value. Current dot next dot data, so this value 65. So if it is greater than thing, that means you are supposed to insert it in this location, current dot next, this location you are supposed to insert it. How can I insert it? So I'm going to say, remember, this is the end of the while loop. So while loop will keep on doing it until two things can happen. What are the two things can happen? You will find a location where you are supposed to insert a node, or you will end up to the end of the list where nothing is available. In both the cases, whether you are supposed to insert it here in this location, in this location, or in this location, in both the cases, current will be pointing to the element. So current will, that is why I use the word current. Current will tell you which is the current location where you are supposed to insert the element, either here or here. When this scenario will come, this scenario will come if this one was 75. Suppose if you are supposed to insert 75, in this case, current will, you compare, is 65 less than that, you make it point to the next element. You make this one point to the next element. Will there is nothing. What is current dot next? Current dot next is null. In that case, you are supposed to insert it here. After the end of the list, you are supposed to insert it. In any case, current will tell me where I am supposed to insert it. So that's the scenario that I have. Now let me just make it as 60. So I am supposed to insert it here. How can I insert it? This again the same story. Make this one, make this new node. This is my new node. Make this new node point to the location where current dot next is pointing. Okay, where this current dot next is pointing, make this point to the same location. So current dot next, wherever it is pointing, same location, this new node will also point. What about the other one? Make this current dot next. Remember, so first thing, what did you do? You take this current dot next, you take this location, the new node dot next must point to the same location. So new will point to the same location. So new is pointing to the same location where this is moving. Now what you are going to do? Current dot next, break this link and make this one point to here. So how is it going to go now? So this current dot next will point to this one, and this will point to the next one. So this isn't that this link is broken. So this is how it's going to look like. If I suppose if I move it here, so this one will point here. This is not null, sorry, this is not null. This will point here, and this will point here, and naturally that null will be there as it is. So null will be here. So current dot next will point to 60, and the 60 will point to this location. So let's write that thing. So what is the first thing that we have done? I will isn't that null will come here. Isn't that the null is here? First one, make this new node dot next must point to the current dot next wherever it is pointing to. So let's do that thing. New node dot next must point to the current dot next. Okay, and what must happen to the current dot next? Current dot next must point to the new node. Okay, new node, done. And that's the end of it. And we are going to say printf inserted. Okay, inserted /n, and we are going to return this one. I think whether you return it or not, this is going to end the function. So if you want, you can just say return the value. So return it, because remember, even if you don't write a return, this is a void. This function will not expect you to return anything back. So I'm avoiding that return. Otherwise you have to simply write that return. Now let's try to go for the delete operation. So again we will go with the delete. Again, delete will not return anything, so I'm going to say delete. Okay, I need a pointer to the header, so I'm going to say struct node. Okay, pointer, and I call it as a head. Head is a pointer to pointer. Okay, and I'm going to say the value that I want to delete. Okay, it's the same thing. Here you said value that you want to insert it. There you are saying value that you want to delete it. Simple as that. How can you delete the node? Okay, remember a few things. Whenever you delete, you must first locate where you are supposed to delete the value. So that is what you require it. And see, remember, deleting is not the thing. When you take a node out, you have to tell the free, or you have to tell the memory that free this location. You have to call a separate function called as a free, which will deallocate the memory that was allocated by malloc. So malloc has allocated, if you look at here, malloc has allocated some memory location. You have to free that memory location. So you need to get, whenever you want to remove an element, you must have the pointer to this location, so that you will tell the free function to remove this, erase this from the memory. So I need one pointer that can do that thing to me. So I will go here, and I'm going to create a struct and node, same thing, node, and say star, okay, temp. Okay, initially it will point to the head, so that here this is the thing. Okay, now whenever we delete a node, okay, we need, so very other thing, whenever we try to suppose let me remove this suppose if you have this scenario, okay, suppose I want to delete this location, I want to delete this one, okay, then you must have the previous pointer, you must have a previous pointer, this pointer must point to the next one. Otherwise, remember, if you just pull this thing out, you lost the link. If you just pull it out, this link is gone. So first you must have established the link from here to here, and then you remove this one. So I need a previous pointer which will say who was suppose if I have to delete this one, I must know who is behind this, that is the previous, so that it will point to the next one. So I'm going to take one more node here, and I will call it as previous, prev. Okay, I will initialize general, first thing I'm going to initialize it as none. Done. Okay, so first thing is somebody has asked you to delete an element from the some location. So that is what we are supposed to do. How can I do that thing? Remember, if the head itself is null, that means nothing is there in here. In this scenario, somebody says, okay, delete 50. Say, remember, this was the scenario. This, you had this list, empty list, and somebody said delete 50. Where is 50? It is not there at all. Okay, so this list is going to be it is not found. Naturally, when the head itself is null, it is you cannot delete it. So I'm not going to say that it is head list is empty or anything. I'm going to say that 50 is not found. That's why I have not deleted. So I'm going to play that trick. So if we go over here, okay, if you find that this temp, remember temp is pointing to the same location. Sorry, this is not temp equal to temp equal to head. Okay, so this is the head. Temp is pointing initially to the head. Okay, temp equal to head. So in other words, so see this temp, let me take this one as temp, temp, okay, temp. This temp is pointing to the same location where the head is pointing. Same location where the head is pointing. Now, if the head is pointing to null, both the temp and head will point to the null itself. So suppose if temp equal to null, that means if the head, this is same as head is null. If the temp itself is null, okay, then I am going to say print f. Okay, I'm not going to say the list is empty or anything. I'm going to say the value is not found. Okay, so I will not say that this and that. I'm going to say you said delete something, that value is not found. So you said delete this value like 50, 40, whatever value, that value is not found. So simple as that. Okay, I will not say the list is empty or anything, that value is not found. Okay, I don't know, you said delete this thing, that is not found. Then I'm going to return out of this function, nothing else I can do with that function. So that is when you are saying that what you say the uh, temp is null. Now what if the temp is not null? So let's look at this scenario. What if the temp is not null? So if temp is not null, in that case what to do? Okay, in that case you have to check whether the value that I want to delete is the first element itself. So this is one other scenario. So let's look at this scenario. In this case, just assume that this temp is pointing to the same location. Let me just pull this here, and so that you won't get. Just assume that both are pointing to the same location. So this and this are pointing to the same location. Just assume, because I'm using Microsoft Word, not a tool that is meant for doing all these things. So both head and assume that head and temp is pointing to the same location, and you have this 45, and somebody said delete that 45. The first element itself has to be deleted, or in this case the 35 has to be deleted. What to do in this case? Okay, how can I delete the element over here? Okay, so very simple. You make the head point to this element. Remember, head and this idea is, look at here. Head and temp are pointing. Just assume that these two are pointing to the same location. Head and this are pointing. Just to make this head point to the next location. Move the head by one location. And remember, temp is still pointing to 35, and use the temp and tell the free function. There is a function called as free function, and tell the free function deallocate it from the memory. So just move the head. Remember, initially head and temp was pointing to the same location. You just move the head to the next location, go to this free function and say wherever the temp is pointing, remove that node from the memory. So it's going to delete that one. So let me type that thing. So if head is not null, that is temp is not null, and temp dot data, that is temp data, temp data, okay, that's the data, temp data, okay, if it is equal to the value that I want to delete, if that's equal to the value that I want to delete, okay, in that case, okay, if the temp is not null, temp is not null, temp is pointing to some location, and the temp dot value, remember head is also pointing, initially head is also pointing, temp dot value, this value is the one that we are supposed to delete. 35 itself has to be deleted. In that case, okay, 35 has to be deleted. In that case, what you are going to do, okay, you are going to say star dot head, okay, move the head by one step. How do you move the head by one step? It is a temp dot next. Wherever the temp is pointing, go to the next location where the temp is pointing. Where is the head gone? I am not typing one letter here. Okay, next. Okay, and free the temp. This is what I'm doing. What did I do? What is this step? If you're wondering, I am going to move this head temp dot next. Remember, temp dot next is this location. Make the head point to this location. Done. And wherever the temp is pointing, free that location. That is what I've done. Make the head point to the next location. Remember, both head and temp was pointing to the same location, and free that one. That is it. And I'm going to say printf, and I'm going to say deleted, okay, percentage d, the element that I've deleted, and I'm going to use /n is for next line, you know very well, and I'm going to say this value I've deleted. Okay, after that I don't want to continue with the function. I'm going to say just return. Okay, this is the first scenario. That was the first scenario. The first element itself has to be removed. So how do you remove the first element? If the head is pointing to the first element, okay, if the head is pointing to the first element, move the head to the next location. Move this head to the next location. Where is it gone? Move the head to this location, next location, and free this from the memory. Free this from the memory. That's simple as that. Done. That's the first scenario. Let's look at the second scenario. Second scenario is this is not the location. You are asked to delete 55. Let's say you are asked to delete 55. You are asked to delete 55. In that case, first get to this location. First go to this location where the value is matching. So if the value to be deleted is 55, so go till this location. So use like in your arrays you are using for I is equal to 1 to n. Similarly, you have to keep on moving the temp. In this case, last time I was using current, this time I'm using the temp. So move this temp here, temp here, temp here, like that. Move the temp until you find the element that has to be deleted. So go to the location. Suppose if it was a 55, go to the location, move the temp to the next location until you find the element that needs to be deleted. How can I move to the next location? Is a temp dot next. You know very well. You keep on moving it. However, there are a few important things. The temp may start moving here, and finally temp may reach up to the null. So if you reach the null, and again if you say move the temp, temp can't move beyond null. So you have to stop until the temp reaches the null value. So as long as the temp is not null, temp has not reached the null, you have to keep on moving. So how can I write that statement over here? So I am going to say while, okay, temp not equal to null. So this is the first scenario, and so temp must not reach the null, and as long as a temp dot data is not equal to the value that I am supposed to delete. Hope you get that thing. So until the temp not reach has not reached the null, and until I have not found the element, suppose if 55 was the element, until I have not found that element, keep on moving the temp to the next location until you find this. As long as the value that I am interested is not equal to this data, okay, then you keep on moving it. So that is what I've written. As long as the data value is not equal to null, keep on moving. How can I move the temp to the next location? So you know very well, to move the temp to the next location, you say temp is equal to temp dash next. So this is how you are going to, how will you make this temp point to the next location? Go to this next, make this point to the same location where the next is pointing. So the temp will point here. How will you move to this location? Use the temp, go to this next here and point to this location. Wherever the next is pointing, bring this one and make it point here. Okay. But very important thing. So the minute you get this one, so now look at here. Temp is pointing to 55. Now what you are supposed to do, 45, you have to bypass this 45. Remember 45 is pointing here. Okay. This if 45 has to be, you have to bypass this 45 and make it point to the this location. Okay, and you are going to free this one. So that is 55, you are going to free it. So you must know the previous location. So whenever the pointer is pointing to the next location, get the previous location. So that is what is the important. So you, before you move to the next location, get the previous location. See, if this is pointing to 55, you must have one other pointer that says this is the previous element, so that use this pointer and make it point to the next element. You need the previous. That is the reason I took one extra pointer that is called as a previous location. So before I move the temp to the next location, before I move this temp to the next location, before I move it to this location, I will make sure that I have the reference to the previous node. So how can I do that? Just store the previous location of temp. Okay, so what I'm doing is, before I move my pointer, suppose my pointer is here, before I move this one, I'm going to take one more pointer, just to say one other pointer. I will make a note of this in the previous pointer. So this is my previous pointer, and then I will make it point to the next element. So before I move, I make a note of previous, so that I know I have the previous location with me. So this is the idea that I'm going to use it. So this is the thing. So I first make note of the previous location, and then I will make it to the next one. Okay. Now as the scenario goes, as you start moving, okay, you start moving it here. Temp is one. Assume that I am taking care of this previous also. I will not show previous, it will become too complicated. So you start from this initial, it is not matching, it is not matching, it is not matching, it is not matching, and finally you find that temp has reached the null. What does that mean? None of the elements are matching. Suppose if somebody says delete 90 from here, you start comparing 90, you say it is not matching, 35 is not matching, 45 is not, this is the 45 is not matching, okay, 55 is not matching, 65 is not, and next one is null. In that case, what you will say, you find that I can delete it because of, see, you won't say that it is not found everything, you won't say stories, you find I can't delete it because 90 is not there in the list. How can I delete the things which are not there in the list? So I've already taken care. Suppose you reach the temp reaches the null, as in this case. Suppose after moving, temp simply moves and it reaches the null. You just say that it is not possible to delete the element because it is not found in the list. So that's simple as that. So if it is not found, how can I delete it? Okay, if it is found, so in this case let us say I want to delete 55. So just say if it is found. So when are you going to get this one? Temp will be pointing to this location, temp dot data. So temp dot data is matching with the one that I want to delete, 55. So let's say I want to delete 55 and there is a match. Remember, I have taken care of the previous, even though I have not drawn, there is a previous one. So this previous one, previous will point to the previous location. Take this previous and make it point to the next location. Take this previous, bypass it. Previous was pointing to 55, bypass it and make it point to the next one. How can I do that thing? Okay, so I am going to go here and I'm going to say, okay, previous dot next is equal to temp dot next. What is this? Previous dot next is equal to temp dot next. Remember, previous was here. Let me just write it. Previous, let's say pre-rev. Previous dot next, so this one will point to the temp dot next. What is the temp dot next? Temp is here, temp dot next is pointing here. So previous dot next is pointing to temp dot next. So it is going to point here. In other words, what has happened is this one is now pointing to this. So it has bypassed the 25. So this link is broken. This is not there. This link is broken. So this is now pointing to 65. So the list is continuous. So you come from the header, you go here. Now you are not going to go here. You go to 65, bypassing 55, you go here. Now you got this 55 here, which is broken. Link is broken, and it is pointed by 50. The temp 55 is pointed. Remove this, free it from the memory. So how can I remove it? So I temp, wherever the temp is pointing, that is 55, this node which has been bypassed, you just remove it. So I'm going to say here free this temp. Done. Free this temp, and because you have deleted it, you are going to say printf. If you are going to say deleted, okay, and slash d and maybe slash n, and the value that you got deleted. Done. So you deleted it. Last one to go. So this is the all the scenarios taken care. You are deleting the first element, you are deleting the first element, or you are deleting the middle element, or you have not found the element. All of them are taken care. Now let's go for one more function, and that function is a display. Okay, I'm going to call this one as a display. Okay, it will take the struct node pointer. It will just take the node pointer, struct node pointer. I will just say node, just the node. So done. Okay, so very simple. You start from the beginning and you start printing it. Now remember, you are just giving the head to it. For this function, you give the head. This function will keep on jumping. For I is equal to 1 to n in your array, how do you write the for loop? The same thing. However, if the head itself is null, you say that list is empty. So in this case, if this list is given, the head is null. So if this itself, the node itself is null, you just say element is the what is that? The list is empty. So if the node, remember I'm not using the word head here. If the node, what you say, if the node itself is null, so that itself is null, then what you are going to say is you are going to say printf, and you are going to say slash n, not Okay, list is empty. Okay, maybe slash n again one more time, and you're going to return out of this function. Done. Yes. Otherwise you have to keep on moving one element until you reach, remember, you start moving from this, from I am going to remove this tempo from here, otherwise you will get confused. You go to this one, go to this one, go to this one, go to this one until you reach the familiar null. Until you reach your null, you keep on doing it. And how can I do that thing? I'm going to use a looping structure, and I'm going to use a while loop. So while, as long as you have not reached the null, so in other words, as long as the node has not reached the null, in other words, you have not reached this location, you are going from here, from here, from here, and so on until you reach this. As long as you are not reached there, you have to keep on showing one element in the list. So I'm going to use a printf statement, printf, okay, and I'm going to show this percentage d. Did I use the percentage? I have a bad habit of putting ampersand there. Okay, so just verifying. Okay, so then I'm going to use this. Don't see, this is just a printing. Don't get confused. This has nothing to do with the arrows that I was using here. This is not that one. This is just for getting it in a beautiful way. That's it. Okay, don't get confused there. And I'm going to print, this is printing. So if I type my name here, it will print. It is a printf statement. So you know which value I am supposed to print, node dash date. So wherever the node is pointing to, print that value. Okay. So wherever the node is pointing, suppose the node is pointing here, print the value. Okay. Then go to the next step, print the value. Go to the next step, print the value until you reach the value. So go to the next step. How can you go to the next step? Node is equal to node dot next. Node dot next. So go to the next, and so on. So go from here, go to the next node, print the value, go to the next node, print the value, go to the next node, print the value until you reach till the end. Once you come out of it, I'm going to use the last one to be printed. Remember, this is just to print. I'm going to say last one is the null. So I'm going to just print. This is printing, remember, just to get the beautiful output. I'm going to say last one is this null. Done. So you're done with the printing part also. You're done. Now let's go to the main part. So quickly we will complete the main part now. So I'm going to use the void here, void main. Okay, let's go here and let's do the void main. And what are the things you need? Definitely you need a structure node, structure node, and I need a head. I told you head, okay, is equal to null. Initially head is null. Okay, then I'm going to ask the user, do you want to insert, what are the actions that you are going to do? So first one is insert, this is what, next one is delete, third one is to display, three choice, last one is to exit. So I'm going to ask the user, enter your choice. So that choice I'm going to use as a ch, and definitely one value is required to insert a value 45, 25, 35. I need a value, so I need that one also. So I'm going to use a while loop here to do achieve this one. So while, okay, the choice is not equal to 4, so not equal to 4, initially I will say the choice is 0. So let's say choice is 0, just to say that I have not made any choice. Choice is 0. So as long as the choice is not equal to 4, you know very well 4 is my favorite choice, and that is happens to be exit. Okay, so I'm going to show the menu print, and I'm going to show slash en dash dash dash, and I'm going to say sorted link list, and dash 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 dash, okay, slash en, maybe one extra slash n, maybe that. Okay, and let's use one more printf statement. So printf, and we are going to start the choice. First choice is choice number 1 happens to be, if you want I can put slash n. Okay, choice not any of slash n is there. So first one is insert, 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 okay, slash en, choice number 2, delete, okay, /n choice number 3 display, okay, /n choice number 4 exit. Okay, that's it. Done. Print f, okay, I'm going to use okay, /en some dash 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 dash, okay, /en, and then I'm going to say enter your choice. Okay, again I will use this one, and one space, extra space I put here, one space there, okay, and I will use a scanf statement, scanf %d and ampersand ch. This is my choice, ch is my choice, so done. Let's use the switch statement for all our work. So we are going to use the switch statement. So we will start with the switch on the value of ch. Then the case number is 1. Case first choice is insert. Case 1. What is that we are supposed to do? In the case 1, I'm going to say print f, and I'm going to say enter value, okay, and one space here, okay, enter value, maybe enter value and space here, okay, done. Scanf, and I'm going to say %d ampersand value. So you are taking the value 45, 25, whatever value you want to insert, you take it. And I have the function. What is the function? Insert is my function, and I'm going to supply the value to that function value. I've supplied it, done. And I'm going to break the switch statement, done. I will just right click and then say format it so that it comes in beautiful way. So this is the first case. Right click and just use the format. There is option format use style, and then you get it in beautiful. Let's look at the case number 2. What is the case number 2? Is to delete. So again same thing, enter the value. I'm not going to type this whole thing, control C and control V. Okay, enter a value, scanf the value. This is not insert, this is going to be delete. Okay, delete the value. Then I'm going to right click and then say format it. So enter and delete is over. Let me just remove one thing over here. Case number 3, case number 3. Okay, where is this thing came from? Okay, this, I think this is the switch statement. Not. Okay, this is the switch statement. Sorry, I pulled out this switch statement flower bracket. Okay, case number 3. What is the case number 3? Case number 3, we are supposed to display it. So we will call display function, display function. So display function. If that display function is not there, display function, what is the name of the display function? So is it not there? So see, okay, this function is there, then I didn't get. Give me an option display function. Nothing else to be done. Okay. Sorry, the display function will take the head. Is it not? Display function will take the header. So I will give the starting point. What is this? Header is not my header. It is the starting point. This is the starting point. You have to give that header. Okay, done with that. Let me use the break. Okay, done. Case number 4. This is the most weighted case that you have it here in the entire program. And what is that? You are going to say /n. We are going to say exiting dash 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 and /n exiting. Okay, done. And we are going to break after exiting, and if you don't know how to type the numbers, then we will say print f wrong choice /n wrong choice, okay, /n wrong choice. So this is it. If you want, you put the break also, because it is the last one. There is no need for doing it. I'm going to just remove all the unnecessary line breaks here. I think one more line break is here, extra lines that I have added. Let me just remove this. Okay, done. Hopefully I have not done any syntax error. Let me just save it, and let me run it. I think it's one mistake that I have done it here. What is the mistake? error function insert. Okay, oh sorry, insert takes two values. What are the two values? One is the head. Look at this insert function takes the address of the head. So the I have not sorry I have not provided that. So it's say what are you doing? Okay, address of the head, address of the head, and then the value, address of the head and then the value. So two things, address of the head and the value. So the things are proper. And the delete function. Okay, the delete function, let's look at this delete function. The delete function is also same because I copy pasted it naturally. If you look at this delete function, sorry, this delete function will take the not the display, where is the delete function? Delete function is the same story because I just copy pasted it. I have a error at both the places. So delete function, that is a delete function. One delete function is same as the head function, that is a insert function. You need this one and you need a value. They both are there. You need to provide the head and that is a node starting point and the value, starting point and the value. Okay, both are done. Let's hope I have not done any more mistake. Where did I, oh sorry, see this is what happens if I start talking. Delete function, sorry, this is delete function, not this is the delete function. I touched the display function, not the display. This is the delete. So even though I'm talking, my mind assumed that this is delete function, but my display function didn't show up. What is the problem with the display function? Is it not closed? Just a minute, I'm sure that it has not closed. It is not, it is closed. Display function, it is not showing me. Strange, but it is you see there delete also it showed me. Okay, let's see, delete you know, let me try and see whether I'm getting some print somewhere. Print has come up. Where is, where on earth is that print? So print, it is a difficult story to find this print. Print f, this is print f, and it has become print. Done. Oh, finally it has shown up. Okay, so let's see what is it. So enter the choice 1, just to display. Let's first display. Oh, this one 466. What is this for? Something display. What is it trying to print? Where is the head? How did it let me just run it one more time. Just to display 3 and equal to null. It should have given me that the list is empty, but it didn't do that. Let me just to close it, just to close it. And the reason could be node is equal to, I am sending this display function, I am sending sorry, again I think I have to check my brain now. This display function, sorry about it, this display function is taking the node and sorry, and I have spent the value, it is head. I'm supposed to give the head starting point, sorry about that. Head, this is head. So again make a correction, too many corrections, but it works. Okay, too many correction, it is a head and this is working. Display one more, display head. Let's try display head. Remember the display function takes the pointer, not the value. That's why it just broke the entire program. Any case, we will try and let's display. List is empty because nothing is there in the list. Okay, just a minute. Okay, so let me try to delete it. Let's go with the delete. enter a value 100, which is not there. Remember, list itself is empty. 100 is not found. Okay, it's not there. Let me insert the element. Okay, 10. I've inserted the value 10. Okay, it just inserted. Okay, let me display the value 10 and next is null. Nothing is there, 10 and immediately null. So if you are getting confused, so this it just simply means that I have inserted. Let's go take this one out. I've inserted a 10 here, 10, and next value is null. 10 and next value is null. Now I'm going to insert 5 here. So 5 here, it must come before the 10. Okay, so 5, if I'm inserting before the starting value, that's the first scenario. Will it work? So let's go ahead and let's do that thing over here. So I'm going to zoom out for you. Okay, so again let me insert 1. Okay, my value is 5. Okay, 5 is inserted. You notice 5 is inserted. Let me display the value 3 here. Display 3, 5, 10. You notice that 5, 10. What does it means? I have it just means that to say that 5 is there. I have inserted 5 here. This is 5. 5 is pointing. Let me take this null here. Okay. 5 is pointing to 10. Let me take this. All these things are not clear. 5 is pointing to 10 and 10 is pointing to null. That means I am able to insert it before the first element. Okay. Will I be able to insert it at the last element? This is, I want to insert here. I want to insert 60 here. Last element 60. Okay, what is this? They are not required. I will insert 60 here. Remember, 60 will be the last element. See, temp is the 10 is pointing to null. I have to remove this null and put this 60 here, and then bring this null to this one. So then it must come 5, 10, 60 and null. Okay, so let's see whether I'm able to do that thing. So I'm going to go again and I'm going to say insert. So insert is one, choice number 1, insert 60. Let me display it. You see 10, 5, 10, 60 and null. Okay, now I'm going to insert in between 10 and 60. I'm going to insert say 25. Again, let me do that 1 and I'm going to insert 25. Let me show that value. Okay, 25 is inserted. You can notice over here. Show the value. So 5, 10, 25, 60. It's done. Now I'm going to delete it one after the other. I will delete the first element here. So 5 I'm going to delete. The first element I'm going to delete it. So I will say delete, okay, the element number 5. Okay, delete 5 is done, deleted. Okay, instead of saying delete, you can use the word deleted. If you are English, if you have studied English, then you can use that word delete. I will in your program. Just I will not rerun the program. Sorry. Instead of saying here delete, where is that? Here I've done deleted, but in that one here D is missing. So just in the first case, that D is missing. Deleted. In the good English is deleted. Okay. So deleted. Here I've written deleted, but maybe that D was that was a typo. So assume that that is deleted. Okay, that one. This is a spelling mistake, not the program mistake. Okay, deleted 5. So what is I'm going to just display it. So the first element 5 is deleted. You notice that the first element 5 is deleted. This is it was starting from previously it was starting from 5, 10, 25. So the first element itself is deleted. So what is happening over here is you removed this 5 from the memory and now it is pointing to this one. Let me remove the last element, that is 60. So let me go ahead and let me delete the last element. I'm going to delete the in-between element because if I delete the last element, I'm left with only 2 elements. I'm going to delete the 25 now. So 2, press enter, and I'm going to delete the 25. Okay, deleted 25. You see that this is coming properly. Deleted last time that word D was not coming, so make it English. So that is English. That has nothing to do with program logic is proper. Let me delete it. Sorry, let me display it. That is 10 and 60. So the 25, whereas this 25 has been deleted, so you are left with the 10 and 60. I'm going to delete the last element, that is the 60th element, this element. So let's go with the 2 and 60 is deleted. Okay, let me display it, and you see that 60 has been pulled out, and you are left with the 10 is pointing to null. Let me get rid of even that 10. So where is this 2, and I want to delete 10. 10 is also deleted. Let me just display it. Nothing must be there in the list. List is empty. Okay, done. With one minor, I hope you will correct that mistake here. That is the word deleted. It should have come. Where is the first one? Here deleted. Kindly adjust that word deleted. It is English. Okay, you are studying English for 2 years. Nobody taught me English for 2 years. Okay, so that's why I don't know English what to do. Okay, so let's go with the fourth option, or the let me go with the fifth option, and it must be wrong choice for the fifth option. For the fourth option, it's most weighted option, that is the exit. Okay, that's all. Thank you for your interest. We will meet again in the other exercise. Thank you.